Okay, good afternoon, dear learners. Welcome to the 11th session on the course Fundamentals of C. My name is Shirish Nagar, and today we'll be discussing on the topic recursion, pointers, and strings. Okay, in last session, we have discussed the topic of functions. So hopefully the learners were able to understand the concept of functions, and the same function concept is being applied for the purpose of recursion. Okay. The guidelines, as you are all aware, it's to maintain discipline for smooth conduction of the live session. And all the learners are requested to type in their name with enrollment number and program name on the chat in order to mark their attendance. You can raise your doubts, questions after the completion of the session and not intervene in between. Okay, so moving on, the objective of the session is to learn concepts related to recursion, introduction and usage of pointers in C language, declaration and initialization of a pointer, types of pointers, pointer arithmetic, accessing pointers indirectly and directly, pros and cons of using pointers in C language, the ampersand address of operator and the dereferencing operator asterisk used in C language. Then we will skip to strings. So we will do introduction to strings and declaration of string and string manipulation operation. So the agenda of this session is quite vast. So we'll be like taking examples swiftly. First, we will be covering the topic of recursion. Okay, so recursion, if you look in the dictionary, is made from the word racker. Okay, in the division, if you have studied in your schools, you must have studied about recurring numbers. Okay, recurring values or recurring decimals. Okay, so what is recurring decimals? Which repeat after a certain time. Okay, or which have repetition. Okay, so when something repeats itself numerous times, we call it to undergo a recursion or we call it recurring. Okay, for example, there is a fraction like 0.33333, right? So what is going on? Again and again you are getting this quotient. So in order to mark it, we sometimes write like this, 0.3 bar. Okay, so that is called a recurring value. So this number 3 is going to recur itself repeatedly. So in the same way, if you talk about recursion, so recursion is nothing but when function calls itself. So when function is capable of calling itself, it is called recursion. So when the function in the body of the function, for example, you have declared a function, let's say f. Okay, and there is an argument. Now in place of argument, in place of this argument, you know about functions, right? We have already studied the concept of functions in the last session. So you know what is function, right? Function generates an output. Okay, like this. And this value is called argument or parameter. So what will happen if this function takes an argument of itself? So it is calling itself. This function is calling itself. And this might happen repeatedly. Okay, this might happen repeatedly till there is a terminating condition for this recursion. Okay, like this. So if this goes on, so what you are observing in this expression? In this expression, you are observing that function is calling itself. This function is again calling itself. This function is again calling itself. And finally, and lastly, in order to terminate, it is calling itself for the very last time. So this is called recursion, right? So why do we use recursion? Because if instead of using iteration or instead of using loops, sometimes it is preferable, sometimes to reduce the lines of code, it is preferable to use recursion. Okay, so by way of recursion, we can break the complicated problem into simple problems. So if we look at the structure of a recursive function, then the recursive function looks like this. Now there is a function definition here written here. Why it is called function definition? Because we are mentioning return type, the name of the function, arguments. Okay. And then uh, in this function, we are calling function statements. Okay. When we are making recursion call here. So recursion call is again, I'm going to call this function name here. So here I will be writing function name args. Okay. So I will be calling this function again and again. Right. So recursion has only one simple advantage. It's that it makes program elegant. It means it is aesthetically very good because the number of lines of code is less if in comparison to implementing the same problem using iteration. But the only drawback with which it suffers is it makes the performance of the system slow. Because if you compare the performance of solving a problem using iteration with respect to recursion, then recursion looks good. Okay, it makes program elegant. It is very aesthetically sound, but performance wise, it is poor. Okay, so if we talk about recursion, uh, recursion makes the performance slow. Okay. So I believe you have understood what is recursion. Recursion is nothing but function calling itself. So we will try to understand this with a very simple example. Okay, so here what you can see is we are calculating factorial of a number. So what is factorial of a number? What is factorial of a number? Let's say if we want to say n factorial. Now what is n factorial? N factorial is n into n minus 1 factorial. Okay, and what is n minus 1 factorial? N minus 1 factorial is n minus 1 into n minus 2 factorial. So can you see there is a recursion building up here? It means the recursion is done with the one step smaller value in order to get the final output. So this value goes on like this, and finally what will happen? It will be n into n minus 1 into n minus 2 into n minus 3, and finally we will reach this number, let's say 1. Okay, so we might reach till n minus n. Okay, so till any value we can reach. So finally we will be multiplying it with 1. So if it becomes n minus n factorial, then n minus n factorial will be what? 0 factorial. What is 0 factorial? 1. So it will be going on like n into n minus 1 into n minus 2 till it is going on till 1. So this is what we call as n factorial. Okay, I hope you are able to understand the concept of factorial. So here what we have done, we have uh, defined a function called factorial. So before we go to this function, let's examine this main function. Because when we have got more than one functions, the program execution begins with main function. So looking at main function, we have declared an integer variable called number. And then we have declared another variable fact of type long. Why we have created long? Because factorials are generally very large values, very large integer values. So in order to accommodate that large integer value, a short integer value will not be sufficient. So this is the reason we make it long. So long by default means long int. Need not to write long int. Instead of writing long int, we simply write long here. I hope you are able to understand what is long here. So long is nothing but long integer. Long integer means very large quantity of integer. nearly of 10 bytes. Okay, it can be of 8 bytes also. So there is also long. Okay, but for the sake of simplicity, we have just used long. So long fact. Now, what is the next statement? To enter a number. Now we are asking the user to enter a number and scanning that number in our variable number. So now the output of factorial is stored in a long value called fact. And this value will be returned by the function call of factorial function. So factorial function will be called from the main function. So this particular statement is your function call. This particular statement is your function call. So function call, in the function call, we are passing the number given by our user. So let's say I have given 5. Let's say I want to find 5 factorial. So the number which I have given to this program is 5. Now what will happen? The function call will be made and this actual argument will be passed and it will be converted into the formal argument. So what is this formal argument here? Formal parameter n. So now n will become 5. Okay. So here n will become 5. Now the remaining process will be done by the factorial function. Let's see what happens. So here n is equal to 5. So first of all, you check if n is equal to 0. If n is equal to 0, I know the value of 0 factorial. So 0 factorial is 1. 0 factorial is what? 0 factorial is 1, right? So if the user has given us to calculate 0 factorial, we will directly return 1 as our answer. But since our 5 is not 0, so we will be going into this else block. So in else block, what we are going to do? We are going to calculate n into factorial of n minus 1. So can you see the function call here? So the function is calling itself. This function is calling itself. This is called recursion. Okay, and it will continue calling itself till the value of n reaches 0. Till the value of n reaches 0. Because as soon as n reaches 0, there will be no recursion. It will simply return 1. So let's see, factorial of n minus 1. What is factorial of n minus 1? And so my n is 5, right? So 5 into factorial of 5 minus 1, which is 4. So now this function is called again, but this time our actual argument will become 4 instead of 5. So what will happen? It will again go into else block. So it will be 5 into 4. Again, it will calculate n minus 1. So factorial of n minus 1 will be 4 minus 1, that is 3. So our n will become now 3. So it will calculate 5 into 4 into 3. And again, this n will become 3. So it will go with factorial of n minus 2. So it will become factorial of 3 minus 1. So it will become 2. So likewise, it will go and continue doing recursion till 2 minus 1. And then we will have factorial. We will have 5 into 4 into 3 into 2. And this time it will be factorial 1 minus 1, which is 0. So at this moment, we will have a n will be as equal to 0. So what we have to do when n is equal to 0? Now there is no function call. Function has to return the value. So the value which the function will return will be 5 into, sorry, will be 5 into 4 into 3 into 2 into 1 into 0. Okay, so it will calculate 5 into 4 into 3 into 2 into 1 into 0. So 0 factorial, we all know it is 1. Okay, so it will calculate this number and it will return the value of factorial of 5. So hopefully with this example, you have understood how the recursion is applied. Okay, is it clear? So there can be other examples which you can look up and find out for calculating factorial. So whatever programs you have been doing with the help of loops, try all those programs with the help of recursion. They all can be done by the help of recursion. Okay, like printing table of 2. Okay, you can print table of 2 or table of any given number n till 10. This can be done by using recursion. So try it out. Okay. So now we come to the topic of pointers. So what is pointers? Pointers are variables, but instead of storing values, they store addresses and addresses of other variables. I think you know this concept that in your memory location, the memory is made up of different address locations. So there is an address at which you store certain value. Okay. So, and this address is referred with the help of a variable. Okay. This memory location is used, this address is being referred as a variable. So there are now three things. There is a variable. So every variable has got two things. A variable has got an address and a variable has got its value. So for every variable, we have got two properties. First is there can be an address of this variable, and then we can have a value to this variable. So every variable is mapped with an address, and at that address, a value is being stored. So if you talk about pointers, they are capable of storing addresses of another variable. Because your variable, if you are using variable, it will directly access value. So whenever you will write printf %d, and then you will write a. So if you are simply mentioning the name of the variable, what you are doing here, you are using the value, you are printing the value of the variable, not the address. But there is another property which is associated to the variable, and that is address. So if you want to store address somewhere, then you will use pointers. So what are pointers? Pointers are the variables which can store addresses of other variables. Okay. So the data type of this pointer variable, because since it is a variable, it should also have a data type. This variable has got a data type. Let's say it is an integer variable. So a pointer in which you are storing address of this variable, this pointer should also be of type integer. So only an integer pointer can store an address of an integer type variable. So there is 1:1 mapping between the data type of pointer and the data type of the variable whose address we are going to store in the pointer. Okay. So pointer allows us to access the memory directly. Pointer allows us to access the main memory directly, and it is a very core concept in C programming language because we use this concept in functions, arrays. Okay. So pointer, if you talk about pointer, it is a derived data type. So why it is derived? Why it is derived? Because it is derived from the type of the variable whose address it is storing. Right. So if you are declaring a variable as a pointer, it is not meant to store values. It is meant to store address of another variable. Okay. So a pointer is a derived data type because whatever data type you are storing the address, the pointer has to be of the same data type. Okay. So why we are storing addresses? What is the need of storing addresses? so that we can manipulate the data of that variable from the pointer. So from the pointer, we can directly manipulate or modify the value stored in the variable whose address we are storing in the pointer. Okay, so pointer points to a data type like integer of the same type. Means if you have got a variable of type integer, then the address of this variable can be stored in a pointer type variable, and this pointer type variable should also be of the type integer. So if your variable is integer and its address you want to store, then the pointer in which you will store this address should also be of data type integer. Okay, how to declare a pointer using this asterisk operator? So this sign is normally people call it star, normally people call it multiplication sign, but technically it is called asterisk. Okay, so asterisk operator we are using to declare a pointer type variable. So how do you declare a variable in C language? You simply write int a. Is it? It's a simple variable of type integer. Now I want to store a pointer. I want to declare a pointer type variable. So I will use this syntax: data type, asterisk sign, and then name of the pointer. So let's say we create a pointer as p. So I have created a pointer p variable. Okay, is it clear? So what is pointer, you know now. So pointer is a variable which stores the address of another variable. Okay. So it's like a shopkeeper who knows your address. I want to go to your house and I am asking people your address. So a shopkeeper knows your address. So I will go to the shopkeeper and the shopkeeper will point me to the direction of your house. So the shopkeeper will work like a pointer. Why? Because shopkeeper is storing address of your house. Okay. Now you get it. Are you able to understand? So I believe most of the learners are able to understand the concept of pointers. Now we are going to delve a bit deeper into this concept of pointers. So how do we use pointers? A pointer is a variable which stores the, as I told you, a pointer is a variable that stores the memory address of another variable. And pointers are used extensively in C language to implement data structures and dynamic memory allocation. Okay, and to improve program efficiency. For using pointers, we should understand two operators. So with pointers, there are two operators involved. First is called address of operator. Address of operator you have used in scanf. In scanf, you have used this operator ampersand. So this symbol normally it is called ampersand, but here this ampersand will be used as a address of operator. So address of operator, if I talk about if I created a variable a, and if I simply write a, I mean the value of a. Okay, but if I write ampersand of a, what do I mean? I mean address of a. Is it clear? So I have created a variable, let's say int a. I am using in an expression a, simply a. So if I use simply a in my expression, just a, I mean its value, the value stored in a. So let's say I write like this: int a is equal to 2. In C language, you write such statements. So if I, in an expression, if I'm using a, what do I mean? I mean value of a. But if I write ampersand a, what do I mean here? I mean here address of a. This is what I mean to say. So are these two same? Are these two same? No, they are not same, because value of A is 2. So value of A is 2. But what is address of A? Address of A is the memory location where this variable is placed, or this value is stored. So this value is stored at a certain address which is being now labeled as A. But address of A is some hexadecimal value. Let's say it can be 0x2FFCD, maybe like this. So this hexadecimal value will be the address of this A. So depends upon the configuration of your system. Depends upon the configuration of your system. If it is a 32-bit value, you will be using how many hexadecimal numbers? One hexadecimal number is corresponding to what? 4 bits. Why? Because 2 raised to power 4 is 16. Okay, so if I'm using one hexadecimal digit, I mean 4 bits. If I'm using a 32-bit architecture, how many hexadecimal numbers do I want? Do I need? I need 4 hexadecimal numbers. So if I'm using 4 hexadecimal number, I will be able to address a 32-bit architecture. Are you able to understand? If my architecture is 64-bit, then how many hexadecimal numbers would I be needing? If my architecture is 64-bit, how many hexadecimal numbers I will be needing? No answer. Great. Okay, think and answer then. I'll not tell you the answer. 32-bit, for 32-bit, I will be needing, for 32-bit, how many hexadecimal numbers will be needing? 8? 8, right? No one corrected me. 8 hexadecimal numbers, right? For 64 bits, 16 hexadecimal numbers. Okay. Oh, think and answer. Okay. So dereferencing operator. Coming to dereferencing operator. So for dereferencing operator, what is dereferencing operator? The same asterisk sign. So when you dereference, what is reference? Reference means address. Okay, reference means address. Dereferencing means remove address. Remove address. So if you put asterisks in front of ampersand, they will both cancel out each other. They are enemies. So here ampersand A is referencing, means you are interested in address. If I want to dereference it, I will put asterisk before this ampersand sign, and they cancel it each other like negative positives. So I will be left with A, which is value. So if I dereference an address, I will get a value. Are you able to understand what is dereferencing? So dereferencing means to remove the reference, and when you remove the reference, you get a value. Okay, so if I have got an expression like ampersand, pointer, asterisk, or ampersand A, if I write such an expression, now can you make out what will be the value? So they both will cancel out each other. Okay, so you will get A. So this asterisk sign is used in different ways in different places. Mostly asterisk sign is used in multiplication, but asterisk is also used as dereferencing operator and is also used for declaring pointers. Okay. So here we are declaring pointer. How to declare a pointer? Same thing, write data type. put asterisk and name of the pointer. So like I write int asterisk q, this example. So what do we mean by that? We have created a pointer of type integer. So since we have created a pointer of type integer, it can store address of an integer type variable. It can store address of an integer type variable. Okay. If I have created a character pointer, if I created a character pointer, what it can do? Character pointer can store address of character type variable. Can store address of character type variable. So pointer points to some random memory address if it is not initialized. So if you don't initialize this pointer, what will happen? If you don't initialize the pointer, what will happen? It will point to some garbage location. It will point to some random memory address. Okay, so that is why it is necessary to always store address inside pointer. Otherwise, it will point to some garbage memory location. It will store address of some garbage value. Okay, so here asterisk is used for declaring a pointer. And how will you store the address? You will store address of another variable by writing this expression. So this is only declaration. Till now, I am not studied. We have not studied assignment. Okay, so forget about this part. This is only declaration, pure declaration. And declaration, what does it mean? Declaration means it is ready now to store address of another same data type variable. So if I have declared integer pointer q, now it can store address of an integer type variable. If I have declared character pointer x, it is ready to store the address of a character type variable. Okay. Now we come to initialization. Initialization means assigning for the first time. Okay, so if I'm doing initialization, I should assign it some value, isn't it? So if I have created a variable, let's say int a, that's a simple variable. Now in the next line, I have created integer pointer p. Now this is a pointer type variable. This is a pointer type variable. I can use this pointer type variable to store address of my a. So how will I write it? I will write p is equal to ampersand a. So ampersand a, how do you read it? Address of a. Is it clear? Is it clear? Address of a. So I have used this pointer variable to store address of another variable. P is equal to ampersand a. Okay. Okay, good. So P is equal to ampersand a. Now answer this question. P is equal to ampersand a I have written. If I put asterisk on both sides of this equation, think it like a mathematical equation. What does asterisk P mean? Now what does simply asterisk P will mean? So if I put asterisk here, I will have to put asterisk here. So asterisk and ampersand will cancel out. So asterisk of P will mean A. Asterisk of P will mean A, that is value of A. And P means what? Address of A. Address of A. Are you able to understand? Yes, Rida has answered it correctly. In fact, Prasanjit has also answered. So, so if I am writing asterisk P, then I will mean the value of A. But if I'm simply using P, I will be meaning address of A. Okay, so most of the learners are able here to comprehend what has been taught. Okay, that's good. Let's move on to the next topic then. So dereferencing a pointer. So same thing. So here there is a pointer variable. So pointer is storing address of another variable. So this is the pointer. So here we have created a variable. I have tried to explain it diagrammatically over here. So let's say we have created a var named variable. I have created a var name variable int var, and the value here is 10. Okay. So int var is equal to 10. So var is equal to 10. Now I am using a ptr variable of type integer. So int asterisk ptr. I have declared a pointer as ptr. Now what I have done to store address of var in this, what will be the next expression here? So I'll be writing ptr is equal to ampersand of var. So ampersand of var is this number 0x7 triple f a whatever. So this is address of the variable var which is now stored at ptr. But if using ptr, if I want to access the variable's value, how would I use the how would I write? I will write here asterisk of ptr. So if I write asterisk of ptr, I mean the value of the variable var. Okay, simply writing ptr will mean address of var. And writing asterisk of ptr will do the dereferencing or indirection. Indirection means remove the direction, and now we are interested in the value. So value is the value of var. Okay, great. So here there is a quick example on how we are going to understand this concept. What we have done in this example, we have declared a variable as digit and we have declared a pointer variable as r. So this is declaration of pointer. And now I have written r is equal to ampersand digit. What I have done by writing this, I have stored the address of the variable digit in my pointer variable r. So now I am printing address of digit. How can I print address of digit? There are two options. Simply I can print ampersand digit. For that, I need a format specifier. So this format specifier is %x. %x is for hexadecimal numbers. So this is for hexadecimal numbers. There is also an option you can use %u for printing addresses, but depends upon the need and requirement of the program. If I'm writing hexadecimal numbers as addresses, I can write here %x. So the same here I am writing r. So simply writing r means address of digit variable. Okay. Instead of r, I could have also used ampersand digit. There is no problem. But since I am studying the concept of pointers, I will use a pointer variable to refer to the address of the variable whose address is being stored in the pointer. So ampersand, either I can write ampersand digit, no problem. But since I have assigned this address of digit variable in R, why not to use that pointer variable? So that's the reason I have written R here. Okay. So what this statement will print? What this statement will print? Tell quickly. This statement is going to print the address of digit. Okay, very good. This statement is going to print the address of digit. Now I'm interested to print the value of digit using pointer variable. So using pointer variable, now I will dereference my pointer. So for dereferencing the pointer, I will write asterisk r. So since asterisk r will display an integer value, this time I'm using the format specifier for integer. Okay, I could have also written digit, but using pointer variable, if I want to print then the value is of type integer, so I'm using %d since it is an integer value. But address is a hexadecimal value, that's why we have used %x. Is this example clear to everyone? Okay, great. So the output of the code is this. Okay. So it will print this R. So R will store the address of digit. Okay. So the digit is the variable. This 100 is the value, and this is the address. Address I am storing in the pointer, and pointer variable has also got its address. So this is the address of the pointer variable because it's a variable. It needs a value to be stored. So this is the address of what? Pointer variable. There is another concept of pointer of pointers. So if I write here pointer of pointer, I can use this address to be stored in another pointer type value. Let's say I create this AA3. Let's say I create a variable Z as pointer. So this Z pointer is a pointer of pointer. So I will declare it like this: integer pointer Z. So pointer of pointers. So this pointer of pointer Z will store address of R, and R will store address of digit. Okay, that is also possible. This is called pointer of pointers. And uh, no matter how chain of pointers you create, you will make program complex. So if you want to print the value of R, so if I want to print the value of R, so if I write asterisk of Z, it will print value of R. So value of R is address of digit. Okay. And if I print asterisk Z, then what will happen? It will print the address of digit. No, it will print the value of digit, right? Okay. So asterisk of Z is R and asterisk of R is digit. Got it? So this also is possible in C language. Okay, but it will make the concept more complex. So it's like a mathematical equation that you solve. So there can be different types of pointers, integer pointers, store value of integer values, or we can call it pointer to integer, whichever way you want to call it. Okay, array pointer. So array pointer have got a very fantastic thing. The name of the array is pointer to its first value, pointer to its first address. Okay, or pointer to its first address. So if I say that if I create an array, let's say if I create an array, okay, let's say how do you create an array? Int a. Okay, let's say I create a array of 3 elements. So internally what happens? We have got 3 memory locations. How they are designated? A0, A1, A2, right? Do you agree with this? So if I simply write A, it will point to A0. So simply writing A it's a pointer to its first address, which is at A0. Okay. So you can also declare a pointer type variable. I don't have any problem. And you can assign it to the address of A0. There is no problem. But why do you need this business? When you can simply use A instead of P. So A will be working as that pointer which will point to the address of the first element. Okay, so if you write asterisk and your name of array name, what will happen? It will obtain the value which is stored at the first element of the array. Okay, this is a fantastic behavior which is exhibited by arrays. And array internally work as pointer. The name of the array works as pointers. So either you create a new pointer and store the address of the first element of the array, or you can use the name of the array itself. This is a provision which is given programmatically. Structures, we will learn about structures. And like structure, we can have a struct pointer. For function pointers point to functions. So you can also have function pointers. Then we have got double pointers. I have already told you the concept of double pointers. Uh, Prasanjit, the value inside the third bracket is the index value. Which third bracket you are referring? Yeah, this number A0. Yes, it's the value. Yes, it's the value, and this is the index. Since you have created array of size 3, you will start counting from 0, right? So 0, 1, 2. So the first element will be referred to the index A0, and let's say we have got a value stored here as 1. So if you simply write a asterisk of A, you will get 1. Why? Because asterisk of A will dereference the address of the first element. So A is automatically pointing to the first element of the array. So A is a pointer which is pointing to the first element of array, and that pointer is the name of the array. So if I simply write asterisk A, you will get 1 here. Why? Because at the very first element A0, you have stored 1 as the value. So the dereferencing works that way. Zeroth index is the default. Yes, you start counting the memory locations in an array from 0. I have like already told it in the last lecture before we studied, arrays, while we were studying arrays. Okay, so you start counting from 0. So it means that if you have got an array of size 3, the elements will be indexed as A0, A1, and A2. Okay, now coming to null pointer. So null pointer means they don't point to any memory location. Okay, so you can assign them as null. So null is a constant here in C, which means nothing. So you can use null type in capital. Okay, and then you can assign it to null. So it will not point to any memory location. And then we have got void pointers. So void pointers are generic pointers because there is no data type associated with that pointer. So you can store address of any data types variable in it. Okay, but problem with void pointer is you cannot dereference them. Means you can not use indirection operator to access the value. They can simply store addresses, but you cannot dereference them to obtain the value of that variable. Okay, that is what we call as void pointer. Then we have got wild pointers. Wild pointers means they have not been initialized. They have been left initialized. But so they are very dangerous programmatically because they can point to a garbage location and they can crash your program. So that is why it is always advisable not to keep your pointer wild. It's like an arrow which can be pointed to any direction. So an arrow which is going blindly can hurt anyone, can hit anyone. So that, or it can hit a garbage value. So that can eventually lead to a crash. So it is always advisable, if you are using pointers in C language, always assign them. Right. Then we have got constant pointers. So constant pointers will not allow you to change the value. You cannot use it for manipulation of the data. So like you can have constants and variables in the case of for storing values. In the same way, you can have constant pointers also. So they will not allow you to modify the value. You can also have pointer to a constant. Okay, so pointers to a constant means the pointers cannot be modified. Okay, so they can access the data pointed by the pointer but cannot modify it. There is also a provision of doing pointer arithmetic. So what is pointer arithmetic? You can increment and decrement a pointer. See, if so, let's say there is a memory location here. This is very interesting concept. There are memory locations. Okay, so there is some these are the pointers. Let's say this pointer P is pointing to this memory location. Let's say 100. Okay, let's say 100 is the memory location to which this pointer P is pointing. Now, if you increment the pointer P plus 1, what will happen? It will point to the next location. So incrementing a pointer will allow you to change the memory location to which it is pointing. You can also decrement a pointer. So the pointer will go backwards. Okay. You can add an integer to a pointer. You can subtract an integer from a pointer. You can subtract two pointers of the same type. Okay. You can compare two pointers. Comparison means you can compare whether they point to the same address or not. Okay. So these all pointer arithmetic operations you can do. So this is a small program which illustrates pointer arithmetic. If you look at this program, what we are doing here is we have declared an array. Okay, so we have declared an array here, v3 with values as 10, 100 and 200. So let's visualize it. Let's visualize it. So here we have got an array of size 3. Okay, so this is 3, 3 locations. So how do you index? You know how to index? What? How will you index this? No, no answer. So your name of the array is V. So V0 is there. Okay, so here we have got V1 and then we have got V2. Okay, and here we have stored 10 and this is 100 and this is 200. Okay, is it clear? So now we have created a pointer variable PTR and we have assigned the PTR with the V. So why V? Why not ampersand V? Because the name of the array is the pointer to its first element. So V here is now being referred as a pointer. Okay, so we can assign one pointer to another. So since we have assigned one pointer to another, it is same as writing PTR is equal to ampersand of the first element. So address of the first element, same as writing this. This expression is same as writing this. So either you write this. So instead of writing ampersand V0, we have used the name of the array. So name of the array is the pointer to its the first element, the first index, that is V0. So I have just assigned one pointer to another. Are you able to understand? Are you able to understand why I have written PTR is equal to V and I could also write ampersand V0? But writing ampersand v0 is equivalent to writing simply v, because v is nothing but v is a pointer which is storing address of the first element of an array. So this is only applicable to an array. Okay, now I am running a loop. So I am running a loop. So running a loop from 0 till 2, because less than 3 is 2. And then I am printing the value of the asterisk pointer, means I am dereferencing it. So dereferencing asterisk ptr will print what? Since ptr is v, so dereferencing it will print what? The value of v0. Okay, so the first time it will print the value of v0, which is 10. So it will print v0. Now I am writing the value of ptr. So I am interested in address of this ptr. So address of this ptr is address of v0. So that is going to be some hexadecimal number. So some hex number is going to be printed here. So after 10, some hex number is going to be printed. Now, what will happen next? I am incrementing the pointer by 1. So ptr plus plus means ptr is equal to ptr plus 1. This time I am now pointing to v1. So ptr plus 1 will mean v plus 1. So v plus 1 will mean what? Address of v0 plus 1. And address of v0 plus 1 will be what? Address of v1. So v plus 1 will be mean address of v1. Address of v1. Don't simply write v1. Prosenjit, it is address of v1. So now my pointer is pointing to the address of v1. Okay, so address of v1. So address of v1 means again I will dereference it and print 100. So it will print 100, and then I will print the address of v1. So it is again going to be some hexadecimal number, previous hexadecimal number plus 1, because addresses in array are contiguous. Contiguous means if it is this address is 1000, this value will be 1002. Why? Because an integer value requires 2 bytes. So it will be plus 1 byte plus 1 address. So one address will depend upon the data type. So if the data type is integer, the accordingly you will add number of bytes. If it is float, you will have to add 4 bytes. If it is double, you will have to add 8 bytes. Likewise. Okay, so every time it is going to print the value and its corresponding address till it reaches the end of the array. Okay, so hopefully all the learners have understood this program very well. Okay. So array and relation, I have already told you, you can either use pointer or you can use the name of the array interchangeably. You can use array elements using pointer, or you can use arrays only. There are some pros and cons of using arrays. Memory corruption can occur. Pointers are a bit complex. They are responsible for memory leaks because you are accessing main memory directly. They are comparatively slower because you have to access memory for accessing values. And if you don't initialize pointer, it can cause segmentation fault. Okay, but pointers are used for dynamic memory allocation. If you want to increase the uh, size of your array dynamically, you can use pointers. Okay, we come to now strings. So quick, okay, I think strings we can study in the next lecture. Let's skip this topic for next lecture. Okay, so that's all. Hopefully you have understood recursion, pointer arithmetic, Pros and cons of using pointers, ampersand addresses, strings. We will cover it in next lecture. All right. Any questions? If you want to ask, you can ask. Okay. All right. Thank you. Happy learning.